So first of all, the idea. I wanted to make a speaker that I could play music wirelessly on from my iPhone, my MacBook or my iPad, etc. So straight off the bat, I knew I wanted to use the AirPlay function of the iPhone, so it was nice, seamless, easy to start playing that music. Now, massive shout out to Aaron, a friend of mine. He's been detrimental with this project, helping me along the way, and it was actually his idea to use the Raspberry Pi and use AirPlay because he was working on a similar project. So using AirPlay, it's not actually using Bluetooth, which is the normal sort of standard when you're playing music wirelessly to a speaker. This is actually using your Wi-Fi, so I don't know if this is better sound quality, etc. I don't have the sort of environment where we could test that, but all I do know is it sounds amazing. We knew we were going to use a Raspberry Pi, we needed some sort of amp and then speakers and the enclosure. So first of all, let's talk about the design. Let's jump on over to Fusion 360 where I basically modeled it, and we'll have a look to see what sort of the size, the dimensions, what it looks like in render, etc. So this is the final design I settled on. Now if you have it standing up, which I think with the base it just looks the best, it's 30 centimeters tall, 14 centimeters wide with a depth of 12 centimeters. So as I said, it's not the biggest speaker, but then again it's not the smallest. I didn't want it to look sort of too intrusive wherever you had this placed around the house. So altogether there is 6 parts. You can have them all 3D printed. Of course you can have one CNC machined. I will be providing the step file so you can get that CNC machined, but this is the overall design that I was going for, and you will be able to get all these files for free, no charge whatsoever on MakerWorld. All I ask in return, if you do download these files, just give me a like and a sub. That would be greatly appreciated, no cost to you. And of course, if you do want to join the Discord and show off your designs or colour schemes you've gone for, please feel free. Again, a link is in the description below. Where it says AirPlay Pod by JP, of course, you don't have to have that. You could just leave it blank. Now, as you can see, it's got a little bit of shape to it. It's kind of curved in the centre, maybe a little bit like the female body form. I do think it looks better standing up rather than sort of flat on its side, and of course the speakers are going to be orientated because they do have some text on them. So next up, let's go over the electronics that we're going to be putting into this, because there is going to be a bit of RGB in there. Nothing over the top, don't worry. It's going to be quite subtle, and it's going to sort of be sound reactive as well, so it's going to be really cool, subtle, and of course you never have to install it. You could just have, like I said, a contrasting plate wherever the RGB is, and it's still going to work great. So let's go over all the components we're going to need, then we can start getting these printed. And yes, I do have a new massive printer. This is the new Bamboo H2S, and it's been amazing. I've been putting it through its paces. No, this video is not sponsored by Bamboo. I paid for this with my own money. It's like the 5th or 6th printer that I've bought from Bamboo. But if Bamboo Labs is watching this video, I'd love to collab with you. Maybe send me a H2D. I'd love to start lasering things. That'd be really cool. Anyway, let's have a look at the components and everything else we're going to need in this project. Now, there is quite a few, but there's a lot of stuff here that's not needed if you don't want the RGB. So this is all to do with the RGB. So put that to one side. And this is all we're basically going to use. Now, this is a Raspberry Pi Zero W2. As you can see, we've got the SD card in there with the software. And then this hat on the top is one of those DigiAmp Plus. And this is a really good amp. It gets its audio direct via the digital GPIO pins, so there's no analog audio going from this, say with a headphone jack or something like that, like normal amps would do. So it's digital audio straight to here, There's no volume or anything like that to worry about. We've got 12 volts in. We have the 2 speakers, which we're going to be using these JBL car speakers. And of course, it does power the Raspberry Pi Zero W as well. And of course, we are going to be using the ESP32 for the RGB. This is going to get its power from the hat as well. So the great thing is we just need this 12 volt adapter. And how this is going to work is this is going to plug into here, which is going to be on the back. And then we can put this on and off switch in line. So that basically gives us the ability to turn it on and off. Now the speakers I went for are these JBL sort of car audio speakers. They're 100mm, which is 4 inches. Now you can use any 100mm 4-inch speakers for this build. It is a good size, it's not too big, so the speaker's massive, the actual housing, and it does fit. And we'll get into the 3D printing parts later, but it does fit on a normal 256 cubes 3D printer. JBL's not the best make. These were £35, about $45, something like that. There is better speakers, cheaper. There is some Pioneer ones that I liked, and then JL Audio also do some. A lot of them are car speakers, but car speakers are actually really good. So I do feel like probably not the best choice to go for, but what I'll do is in the description below I'll put like 4 or 5 different options that will work really well this project, and I don't know, maybe I'll swap them out later down the line. We do have wire connected. These are soldered in, basically just normal wire, which these are going to obviously go into these pins. We actually do have to do a little bit of soldering. I lied, we need to solder this switch in, but minimum soldering. Everything on here has already been done. Now this is the ESP32 and this was provided by JLC PCB, and they are today's sponsor, and we'll have a look at that in more detail in a moment. We have, it looks like there's a lot going on here, but there's actually not. This is the 5 volt power that we're going to steal from the DigiAmp. This is a microphone, so we can do the sound reactive. Again, that's optional. You can still have the RGB without that. And then the 3 wires for the RGB, which is ground, 5 volts, and then the data. And then this little thing here is just a kind of little bodge makeshift Wi-Fi extender antenna for the ESP32. Now these ESP32s are made by JLC PCB, the sponsor of today's video. They'll bring your ideas to life in their state-of-the-art facility. They have experts on hand, and of course they are very competitive on pricing. But how do you actually go about ordering PCBs? Well, let's order the PCBs for this project. Drag and drop your Gerber file across, give it a chance to load. We can see the PCB images here. It will show you the dimensions, so you can double check that. It will show you how many layers are on it, and you can choose how many you want. Further down, we can choose the thickness of that PCB, and of course my favourite part, you can change the colour. They've got the normal green, purple, red, yellow, blue, white and black, but my favourite is the white. Now they have more options, and as you can see down here we can do the pick and place, but if you have a look at the price, they are $2.10 for 5 of these ESP32 boards. Ignore the shipping. No one wants to pay $21 for something they paid $2 for. Change this to global shipping standard and it's only $1.50, making this a really affordable and cost-effective way to bring your ideas and projects to life. So for more information and the latest offers, check the link in the description below. So thanks again to JLC for sponsoring this video, because projects like this just wouldn't be possible without them. So that's all the electronics. Now it's time to get everything else printed on the H2S and have a look to see what they come out like. Now, as we print these parts off, let's talk about the H2S quickly. I did buy it with my own money. I've been exclusively using A1s and A1 minis for the past year, but it's so nice to have a much bigger build volume, and the printer is fantastic. It's absolutely amazing and I highly recommend it. It's just been amazing since day one. So as you know, this is 3D printed and this is the design that I went for. I think it looks pretty cool when it's standing upright like so, and of course I did design a little stand for it, so that will go like that and it will stand upright, and I just think it looks really cool. It's not too big and it's not too small, where the sound quality is actually really nice off this, because I have obviously put one together already, a purple one. Let's have a look at the other parts. So this is the back, which will basically go on like so. Just need a little bit of cleanup, but this is where the power switch is going to go, and then the audio input. We've got two sort of vents here for the speakers, and then this is where the digiamp and the Raspberry Pi is going to go. We do have a little cover which says AirPlay Pod by JP, so that's a nice little touch. Then we have the main piece for mounting the speakers. So this will basically go, as you're looking at the front, this will basically be this way because the speakers will be mounted behind it. Let's just chuck that in there roughly like that. Now you can leave it like that, but I decided to have some kind of beauty panel on here just to give it sort of the green depth in there, and then we need to put it together first, but as you can see that's going to look really cool. Now 3D printing this is fine, but I thought it'd be really cool to get JLC CNC to make this really nice one out of aluminium or aluminum, and it's really strong, really sturdy, it looks amazing. I've done it in champagne because it's the closest to the actual current colour scheme, but I guess I could have done this in dark green. That might have looked really nice as well, but as I said, this is a really nice part. It looks really good, it's super strong, and they're not that expensive. Now there is one last part that I haven't mentioned so far, and that is, so this is going to allow the RGB to shine through, and this is basically clear PETG, translucent or transparent, whatever you want to say. And you probably noticed when I put it in there, there's a bit of a step up, and of course that is by design for when this plate goes on, then it's nice and flush. Yeah, it looks really good. Like I said, it doesn't matter if you 3D print this or if you get it CNC'd, it's just going to look that little bit more special with the CNC. And like I said, for less than $30 shipped, that's just going to look fantastic. So now we've got all the parts we need, and we've got everything else 3D printed. We've got the CNC machined front panel. Everything's looking great. So we're going to get it all put together, but before we can do that, we have to set up that micro SD card. Now we are going to be using the Raspberry Pi and the light version, so it's not going to have any GUI. We're going to SSH into it, and then we can get everything set up. Now I know this might seem a bit daunting to anyone that's never used Linux or SSH run commands, etc., but trust me, if you follow this video, and there is a written guide as well which I'll link in the description, it's actually relatively easy to do, and as long as you follow it to the letter, you can't really go wrong. So let's get that SD card set up, get all the software on there, and get it all configured. So probably not the most fun part of this build, but I've included as much as I can. So we are going to be using the Raspberry Pi Imager, links in the description, and I've got the Raspberry Pi 02W. Now, to actually record this footage, I used a different Raspberry Pi. I used a Raspberry Pi 4, but it makes no difference whatsoever. When choosing the operating system, we want Raspberry Pi OS, but the ones on this main page, they have a GUI interface and they're a lot larger. We don't need a GUI interface. We want Raspberry Pi OS Lite. It's all command based, because it's not as if we're going to be plugging this into a monitor or anything. Choose your storage. I use a 32 gig micro SD card. Then we need to edit the settings. This is very important because we don't have that GUI. We're going to give it a host name. Now I'm just going to call mine JP, but please note that whatever you call it here, this is what's going to show up on the iPhone or iPad as the AirPlay device to connect to. So I actually called my other one, the main one you see in the video, I think I called it something like AirPlay Pod or something like that. You need a username and password. Don't use the one I've used. It's a very bad password. Password 123 is not recommended. Next, we need to add it to the Wi-Fi network. Obviously I've blurred mine out, but you want to give it the SSID, so whatever the Wi-Fi is called, and then put in your Wi-Fi password. Again, I'm going to hide mine. You need to go to services and enable SSH and use password authentication. There's nothing else you need to change in options. That can stay as it is. Hit save, and then yes, we want to use those customized settings. Yes, wipe my SD card, etc, etc. This is going to take about 8 to 10 minutes. So of course I just skipped ahead. You can click continue here, take out the SD card, pop it into the Raspberry Pi and power it up. So next it's time to SSH to that Raspberry Pi. So you type SSH JP at and then the IP address. Click yes, put your password in, and then now we are connected. Now there is a website with all the commands, and I will put that in the description below. It's very simple. It's copy and paste the commands across. Now I'm using a MacBook and I'm using Terminal. It was just the easiest way and the most convenient way for me. Now of course you can use Windows and PowerShell or a dedicated SSH program. So I'm just running these commands. It's pretty much a copy and paste situation. Now unfortunately with the version that I was using, I didn't have Git installed. So just type in sudo apt install git after you've done the sudo apt upgrade, and that will install Git. Then we can carry on with the rest, and again, this really is just a copy and paste situation. We're just going to be copying the commands from the website. Again, I will have a link to this website in the description below. It's called Pi My Life, and we're just going to go through every single one of these codes. I am showing you here, but speeding up the sections where it does the install of me using each code, just so you could come back to this and use it for a reference. The Git code was the only one that I had to run that wasn't in the site. Maybe things will change in the future, I don't know. So we're just copying all these commands across. Don't ask me what they're doing because I don't really know too much about Linux or these commands that are being ran. It's something that I do want to learn more in the future, but for now we're just putting all these codes in, copy and paste, and it's doing its magic. So when we get to the make and sudo make install, this is actually compiling the AirPlay software, if you like, compiling it and then installing it. So this won't actually take that long. I think the whole process from start to finish takes about 15-20 minutes, and most of the time you're just waiting for codes to execute. So these two codes, the one above it and the one we're just running now, they're to enable and then start that service. Now we're going to run the update. Again, this can take some time. Remember, there will be prompts where you have to click yes. And then at this point, things were a little bit different. We want to open a configuration file. So we're going to type in sudo space nano /boot /firmware /config.txt. And this is going to open the text file, just as you see here. Now we are going to add a new line of code in here, which you've just seen me do at the top. This is in the guide. And then this piece here, I'm going to remove the hashtag, which turns that on for the I2S, because we are using that digiamp. So we need that turning on. Then we can do the Control X or Command X to save it, hit yes, leave it named the same thing, push enter, and then now we can open another config file, which is in the guide, and we're looking for the volume range. Here we go, volume range dB60. We want to uncomment that. We're going to change this value to 30. And then we can do the same, command and save, etc. Sudo reboot, and everything is done. When it reboots back up, it should be ready to go. So hopefully you've made it this far and you've done your little test, made sure it's playing music and everything's sort of working out okay. Now we're on the final stretch. We're going to get everything put together and then we can have a look at the final results. Now of course this will be a time lapse, but I'll give you a few pointers along the way. If you do need help with this project or any of the other projects we cover, join the Discord. There's a link in the description below. I'll be more than happy to help you out. And if you don't have a 3D printer, maybe I can print one for you. We'll sort it out. Just join the Discord and send me a message. Right, it's time to go back to the top-down camera and start putting this all together. So as I said, we're going to do a time lapse. First of all, I'm going to put the LEDs in. I was thinking about putting the speakers in next, but it wouldn't work. Then we've got that PLA transparent section for the RGB to shine through. We're going to put some super glue on that. We spray the activator so it dries super quick. Next, we're going to put the screws in the actual speakers. Now these are those weird screws that sometimes you use on PCs with fans. I will put a kit in the description which has all the screws for this project, and it's basically just like a PC kit. Anyway, we've got the two speakers on. The ESP32 is next, and I just super glued it to the back of that RGB clear, sort of show the LED through board. So next I realised that one of the power cables came off for the ESP32, so I had to quickly put that on. Next we've got the main section and then the CNC panel, and we put that all in, and then I'm going to glue, this isn't the best way, but I am actually going to glue the green sort of section in with the speakers on it and then spray that activator, and it will sort of get it all stuck in place, no problems. Thinking about it now, there's probably a better way I could have done that, maybe when I do revision 2. We've got the back panel. I'm putting in the DC jack and the power switch. We're just going to solder those two wires on. That's the only soldering I actually did on this part. We've got the Raspberry Pi and that other board in there. We can see the glue's all dried, so I'm just tidying things up here. We're going to get those wires connected to the digiamp. They're just sort of screwed in. Then we've got the top panel, AirPlay Pod by JP, tiny little cutout at the top, and that's going to be for the power and ground for the ESP32, so we get those plugged in. We put two screws in the back. I wanted to make sure it all worked first, and it does, or the RGB lit up. I did go through, play some Foo Fighters, but I will actually play some music on it so you can hear it later. Now, I did make sure everything was working at this point, and then it was time to basically button it up. So we're going to add all the rest of the other screws to the back, and that's pretty much it. It's all built up. So I guess it's time to look at the final results. Now, just a quick note here, I am going to be recording the audio from the speaker with microphone, so I know it's not a great way of sort of hearing the audio quality. You'll just have to take my word for it. It does sound really good, but as I said before, these speakers are probably not the best ones for this setup. I think if I'd have paid a little bit more money, I'd have got a lot nicer speaker. But we live and learn, don't we? And I might upgrade them in the future, or maybe when I do the V2. Anyway, enough waffling on. Let's have a look at those final results. Now it does sound really good, and it's extremely loud for its size. If you put this full blast and you're in the computer room, you can pretty much hear it down the street. It is really loud, and the audio quality is still really good when you get to those higher levels. So that about wraps it up for this video, but as always, thanks to JLC for sponsoring this video. I hope you enjoyed this content. I'm really looking forward to doing a V2 of this, maybe a smaller one with a single speaker. I don't know, just sort of change up the design a little bit. We'll have to see how it goes. Now, of course, if you do enjoy my videos, I'd really appreciate it if you liked, subscribed, and then don't forget to hit that bell icon so you don't miss any future videos. I'm JP, and as always, I'll catch you in the next one.